Good day, everyone. Our topic here is on parabola. At the end of the lesson, you will be able to define parabola and determine the equation of parabola. Let's have the definition of parabola. It says here, it is a set of all points P such that its distances from a fixed point F and from a fixed line L are the same. I will present here a video clip that clearly illustrates the definition of parabola. I copied this on YouTube.
First, we begin with a point called the focus, and we'll draw a horizontal line called the directrix. Now let's draw a vertical line from the focus to the directrix and create the midpoint so that both line segments have the same length. Now the focus and the directrix will remain stationary, but as we move the point in between, notice that we want the bottom line to move along the directrix so that it is always perpendicular. In order to create the parabola, we will move the point in between such that both lines are always the same length. As you can see, the path of the point creates the shape of a parabola.
There are two terms which are very important in sketching parabola, focus and directrix, such that the fixed point is called focus and the fixed line is called directrix. Focus is denoted by F and directrix is denoted by L. Now we have the standard equation of parabola. For a parabola with vertex at the point 0, 0 and open upward, the equation is x squared equals 4cy. For a parabola that opens downward with vertex at 0, 0, the equation is x squared equals negative 4cy. For a parabola with vertex at 0, 0 and opens to the right, the equation is y squared equals 4cx. And a parabola with vertex at 0, 0 and opens to the left, the equation is y squared equals negative 4cx. There are four different forms of equation when the vertex is at 0, 0. Let us go back to the previous slide to observe differences and take note on specific properties. The difference between equations 1 and 2 is the sign on the right side of the equation. If it is negative, it refers to a parabola that opens downward. The parabola is extended downward, whereas the equation x squared equals 4cy, which has the positive sign on the right side of the equation, is a parabola that opens upward. In equations 1 and 2, x is a quadratic term and y is a linear term. Its equation has a factor c on the right side, which represents a very important property. This c value refers to the distance from the vertex to the focus and from vertex to the directrix, or line L. The directrix for equations 1 and 2 have horizontal directrix, which is below the x-axis for equation 1 and above the x-axis for equation 2. Since it's a horizontal line, then it will pass through y-axis. Its equation is y equals negative c if it passes through below the x-axis, and y is equal to c if it's above the x-axis. The axis of symmetry for both illustrations is perpendicular to x-axis and passes through the vertex. Hence, its equation is x equals 0. Take note that in a parabola, the directrix or line L is always at the back of the parabola, and the focus is inside the parabola, and the axis of symmetry is always perpendicular to line L. In equations 3 and 4, the variable y is squared, and the variable x is a linear term. Equation 3 has a positive term on the right side of the equation, and its graph opens to the right. Equation 4 has a negative term on the right side of the equation. Its graph opens to the left. The directrix are vertical lines, and that pass through the x-axis. This means that the equation of L is x equals negative c or x equals c. The axis of symmetry for both illustrations is y equals 0. Let's have the standard form of parabola with vertex at xk and opens upward or downward. Observe the equations. Both have quantities with the same variable. Variable x is with h and variable y is with k. For a parabola that opens upward, we have positive sign on the right side of the equation. For a parabola that opens downward, a negative sign is indicated on the right side of the equation. The axis of symmetry for both illustrations is x equals h. For both equations, the quantities x minus h is raised to 2 and y minus k is raised to 1. For equations 3 and 4 with vertex at xk, give us quantities y minus k raised to 2 and x minus h raised to 1. Observe that y is always with k value and x is with h value. The axis of symmetry for both equations is y equals k. To recap, there are 4 different equations for parabola with vertex at 0, 0, and 4 different equations for parabola with vertex at k. Observe properly the equations. In parabola, we always have vertex, opening of the parabola, axis of symmetry, focus, and directrix. Let us consider some examples. Example 1. X squared is equal to 12y. This is patterned to the form x squared equals 4cy, such that c is equal to 3 to make it 12. Therefore, the distance from vertex to focus and from vertex to L is 3 units. The illustration shows the properties of x squared equals 12y. Example 2. X squared equals negative 4y. This is patterned to the form x squared equals negative 4cy. The negative sign refers to the graph which opens downward. The value of c is 1, which is the distance from vertex to focus and vertex to the directrix or line L. The illustration shows the basic properties of parabola. Example number 3. Y squared equals 8x. Y is squared, so the graph could be opens to the right or to the left. But since the right side of the equation is positive, then the parabola opens to the right. This numerical value 8 should be transformed with factors 4 and c. Hence, c is equal to 2, which is the distance from the vertex to the focus or vertex to L. Example number 4. From the given equation, determine the following: vertex, opening of the parabola, focus, directrix, and axis of symmetry. The given equation is y squared equals negative 6x. The equation is patterned to a parabola with vertex at 0, 0. Since we have a negative linear term on the right side of the equation and we have y squared on the left side of the equation, then the parabola opens to the left. After identifying the vertex and the opening of the parabola, it is helpful to make a rough illustration of the parabola with its properties. We need to know the value of c. Using the standard form, y squared is equal to negative 4cx. 6 from the given equation is equated to 4c. To solve for the value of c. Hence, c is equal to 3 halves. With this, we can have the coordinates of the focus. Point F is at negative 3 halves, comma, 0. The direct text passes through the positive x-axis. Therefore, this equation is x equals 3 halves, or it could be simplified through having this equation, 2x minus 3 equals 0. The axis of symmetry is y equals 0. Example number 5, the square of the quantity x plus 3 is equal to negative 12 times the quantity y minus 2. The given equation is patterned to a parabola with vertex at xk. X is to be determined to the quantity with x variable, and k is to be determined to the quantity with y variable. The quantity x plus 3 and the pattern x minus h gives us an idea that h is equal to negative 3, with k equals 2. Hence, the vertex is negative 3, 2. It opens downward because the factor 4c is negative. C is solved through 4c equals 12, such that c is equal to 3. If the standard equation of parabola is transformed by expanding the parentheses and collecting terms, then we are transforming the standard equation to general form. For example, the standard form, the square of the quantity x minus 7 equals negative 24 times y minus 6, is simplified. Then we have x squared minus 14x plus 49 equals negative 24y plus 144. We collect terms from highest degree and equate to 0. Then we have the general form, x squared minus 14x plus 24y minus 95 equals 0. The general forms of parabola with vertex at xk are written in these forms. First, we have x squared plus 3x plus ey plus f equals 0, where e must not be equal to 0. Second, we have y squared plus 3x plus ey plus f equals 0, such that d must not be equal to 0. For practice and to explore solving problems on parabola, we have here 3 problems. If you have queries and answers to this exercise, just comment below and don't forget to subscribe.